Good morning, friends. So far, we have seen how to develop Spark-based applications using Scala IDE as interpreter. Now we will see 1 minute. Now, first we will see how to externalize the application, and then we will get into accumulators and broadcast variables. Most likely, I will be able to cover both the things. If not, we will continue tomorrow. So let me go to the course page. So we are done almost up to here. Today we will see how to externalize the program and then how to build it and run it on a cluster. In the last class we have built the program, but we have hard coded the input path, output path, and also the mode in which the application need to run. Okay, so let me start my STS. So first thing you need to do is there are two things which you need to keep in mind. If you open the application which we have developed as part of the last class, there are a couple of things which we hard coded. One is the input path, this one, and also the output path to which the data needs to be stored. And also we are not handling any situations. We are not validating whether the input path exists or not, whether the output path already exists. If the output path already exists, do we need to create the unique directory or delete and recreate a new one? So it all depends upon how you want to deal with it. Okay. And also you see the application name here. We can set whatever application name we want. In this case, let us name it as average revenue per day. In some cases, even this one will be externalized, but the input path and output path are typically passed as parameters. Sometimes they are also externalized. So you need to understand the difference between passing passing the parameters as argument, and externalizing the parameters. So when you pass the parameters as argument, when you run the application, you have to pass all the parameters in the command line. When you externalize, you create an externalized file in some standard directory such as source main resources, which you can see on the left side. And then we will pass that file and we will replace certain variables at runtime. So in this case, what we will do is we will pass input path and output path as parameters in the form of arguments, and then the mode in which the application need to run, whether it has to run in local mode or in yarn mode, we will try to externalize it. For that, we need a Scala package called typesafe config, and first we need to add that to the sbt build.sbt file, so that the dependencies are downloaded. Okay, so the way you do is okay, so we have this September 2016, and then we have the demo Spark Scala, which I have tested already. So if we go to demo Spark Scala and cat on build.sbt, so this is how you can actually um, add the new dependency to the existing application. We just need to add this line to the file. Okay, you can see these instructions even in the blog. Let me move this aside. here. So as we have added the Spark based dependencies to the application, we have to add it to the uh, we have to add the config also to the application as dependency. Once you save it, okay, so you have to run SBT package so that it download the dependencies. Even before you make the changes, you have to first run the SBT package so that it download all the dependencies required for the typesafe config. And once SBT package is run, you have to run SBT Eclipse also. If you don't run SBT Eclipse, the class path file will not be updated. So now if I check for typesafe, sorry, config, probably they might be related to something else. To make sure that they are added to the class path, you have to run SBT Eclipse. You can also validate by running ls-altr. Now the size of class path is 15 KB, and if I run SBT Eclipse, the class path will be updated. And yeah, it is still 15 KB because I think there are some other components which have downloaded the typesafe config packages. Probably the Spark already have that. Okay. Anyway, you always when you add the new dependencies, it's better to run SBT Eclipse so that the class path is updated. Otherwise, you might run into some class not found exceptions. Okay. Now we have created the dependency. We have to add a configuration file. So if you go to typesafe config documentation, it's related to Scala. It's nothing to do with Spark. If you search for Scala typesafe config and go to the official documentation in GitHub, it expects the configuration files in a standard format. Uh, you either you have to name it as application.properties or application.conf or application.json and few other names. So there are only some standard names which you need to follow when it comes to using the typesafe config package as part of your application. Okay. So here what we'll do is we'll create a file with name application.properties. Okay, and in this we will actually define the properties. One of the standard way, there are multiple ways where you can define the properties. If you want to have different properties for different environment, for example, dev might have different types of properties and associated values. The names of the properties might be different, sorry, might be same between dev, QA, and prod, but the values can be different. I will show you an example so that you can understand. If you go to my existing demo Spark Scala, and if you go to resources, if you look into the application masters, the actual parameter name is deployment master, but I'm saying dev.deployment master. So when I actually run it in the in development, I will try to get the value associated with it. When I try to run the program in production, I will try to get the value associated with it. So in this case, if I create application.properties with these two values, okay, and then we have to make the modifications to the code. Okay, in this first we need to load the application.properties. So the way you can load the application.properties is using this config factory.load function. Okay, so that should be the first line so that we can read the parameters anywhere we require. Here it is complaining because we haven't imported it. So let us import com dot typesafe dot config dot config factory. Okay, once you imported, the error is gone. Now we have to read the dev related parameters. So for that, what we have to do is, instead of hard coding local here, we have to say appconf, sorry, yeah, appconf dot get config. Okay, and I want to pass whether I'm running in development or production as parameter. Okay, so in this case, I will take one of the argument which will pass the environment in which we are running. So in this case, let me run it as let me take it as the third parameter. Okay, so I can say args of 2, which will become the third parameter, and then I can say get value and deployment master. Okay, let me see something is. Let me pick it from here. Okay, get string, not get value. That's the problem. Okay, so now what is happening is, when I actually run this program, I will pass the parameter as dev or prod um, uh, um, third parameter, and then uh, so there are means in actual production case scenario, this application dot properties will not just have which deployment master we are trying to use depending upon the environment. If you are trying to connect to a database, you will also have a parameters with respect to database, such as dev.hostname, whatever is required to build the JDBC URL. What all we require? We require hostname, we require port number, we require database name, we require username, we require password, right? So all these can be required to connect to a remote database to build the JDBC URL. For dev, we will typically use a different database, and for production, we will typically use a different database. And we should not hard code all these values as part of the program. Instead, we will externalize into this application.properties, and then we will load at runtime, and we will and then run the application using the values from the properties. Okay, so in this case, we will just use one parameter. So you might feel that we are doing too much to get the one parameter. I am showing an example to demonstrate for deploying the application. But in real world scenario, there will be many parameters which will be externalized like this. So you need to understand the value of externalizing all these parameters. Sometimes even the input path and output path also are externalized. But in most of the cases, typically input path and output path, at least the base directories for the input path and output path, are typically passed as arguments to the application. They don't externalize into the configuration file, but in some cases they do. It all depends upon how you design your application. Okay, so now we will actually get the input path as well as output path. We will try to pass those things as parameters to our application. Okay, so here what I'm trying to do is, I'm trying to create a variable which says in path or input path, and the first argument, so there is a question from Jiva. Yeah, so you need to understand the difference. Args is the one which is passed at runtime using command line. Here we are actually loading the values from the application.properties. Okay, so this args dot so for, to determine whether we want to use we are running in development and production, this value will be passed as command line argument. Okay, we are not actually getting this value from the application.properties. We are actually um, where is this? We are actually getting the parameter which will determine whether it is running in development or production as the one of the parameters in command line. I will pass it as the third parameter. Yes, that will be the third parameter which will be passed at the command line. Wait until I am done, you will understand it clearly. Okay. The first parameter is input path, and second parameter is output path. Okay, and third parameter is the environment where we are running the application. So these three parameters will be run as part of a Spark submit job, or when we right click on this, if you are using Eclipse to run the application, go to run configurations, and when we actually go to arguments, here we will tell what is the base directory for the in path, what is the base directory for the output path, and then the environment in which it is running. Okay, so let me cancel it. Yes. Okay, so here so in path we will only pass the base directory in which we have orders, order items, and all the other tables. So we have to say this one. Okay, so this will actually refer to the orders directory. Similar is the case with this one. Okay, and now if you want, you can add the logic to validate. I will directly copy paste and explain. So I'm just validating whether the input path exists or not. To check whether the input path exists or not, you have to add these lines of code, and I will explain the logic behind those lines. It's primarily Scala based code with Hadoop based APIs. Okay. So file system is a Hadoop package. So again, it is complaining because it is not added in the import command. So we have to say import arc dot apache dot hadoop dot fs dot file system. If you are not sure, just Google it and you will be able to get it. Similar is the case with path, and path also we need to import. So let me get it from here. Okay, I just have to say fs dot underscore rather than importing the specific class. Now the others will be gone. Okay, here it is in path out path. Okay, so what we are trying to do is there is a file system dot get, and we are actually getting the Hadoop configuration, and we are actually creating an object of type file system. So FS stands for file system, means we have created the object of type file system by using this function file system dot get sc dot Hadoop configuration. So sc, what is sc? Sc is nothing but Spark context. So when we actually create the Spark context, it will also have inbuilt Hadoop configuration. When you are running in the cluster, that Hadoop configuration will be retrieved from the XML files. Okay, so here we are trying to get Hadoop based configuration, and then we are creating the FS object. So file system dot get method is nothing but it will create a file system object internally. So once you have the file system object, you can check whether the path exists or not. So fs dot exists just returns Boolean. If the path exists in the file system, it will return true. If the path does not exist, it will return false. Okay, so here we to use fs dot exists, we have to create the path object, whereas our in path is nothing but string. So the data type of the input path and output path is nothing but string, because args is of type array of string, and args of 0 is just one string element. Args of 1, which is out path, is just another string element. Okay, so we are trying to create a path object out of the string, and then we are actually passing that path object to fs.exists method to confirm whether it exists or not. If it exists, this will return true. If it does not exist, this will return false. And input path exists will be true if the path exists. And if it does not exist, I want to just throw an error saying input path does not exist and return. In this case, I'm just printing. Typically, we will raise the exception and we will come out of the program. We don't print and we don't return in case of actual application development. In the actual application development, we will raise the exception and we will come out of the application gracefully if there are scenarios where we should not proceed further. Okay, and for the output path, if the output path already exists, we just want to delete it. So we can say if output path exists, in case it exists, I just want to delete it. So the delete is just fs.delete. Okay, at times when it comes to MapReduce programs, we want to create a unique directory in some of the cases. In some of the cases, we just want to delete and replace it. In some of the cases, we want to create a subdirectory under a base directory, which will be passed as parameter with some unique name. It depends upon your application requirement. In this case, I'm just deleting it so that a new directory can be created. Even if we run multiple times, it will not fail. It will just delete the existing directory and it will run it. Okay, and then we have to use out path here. Okay, so the file and the output of the data will be written. Sorry, the output of the program will be written into the path which is specified as output path. Okay, now I will right click on this, run as, run configurations. We have to give the input path as first parameter. And the first parameter is /users/ Raju research data retail _ db. That is the first parameter. And the second parameter is, I just want to store the output here, output, and third parameter is dev. So this is what will be used to fetch the appropriate parameter from the properties file. Okay, so click on apply, click on run, and now the application is running. Okay, so it is done. So the application and the data is just created, the file is just created. Okay, so this is how you can actually externalize. Again, I am explaining the logic of externalizing certain parameters and passing certain parameters as arguments. Okay, in this case, we are passing input path, output path, and the environment in which it is running as parameters. So there are three parameters. Input path is being used to read the data, output path being used to write the data, whereas the third parameter, which is the environment, is used here to get appropriate parameters at runtime to run our application. So typically, we will not only use the cluster mode in which it is running, we will also focus on many other things in true production scenario. One of the cases, if you are trying to connect to a remote database as part of your application, all that information will be externalized, and also at times we will also externalize the file name pattern. So let's say you have the output directory, and you pass the output directory as a parameter, and you want to create unique directory under the output directory. The naming convention for the subdirectories to generate that unique name can also be externalized. So there are many cases where we typically externalize the parameters. You will not be surprised even if you see hundreds of them in some of the complex applications. Okay, so you need to be familiar with both aspects, how to pass arguments and also how to read externalized parameters when you try to develop the applications irrespective of the programming language. Okay, any questions here before we move on to the next topic, broadcast and accumulators, broadcast variables and accumulators? Okay, so we'll move on to the next topic, which is accumulators and also broadcast variables. So even when I actually develop, oh, sorry, before getting into that, let me compile this application into a jar file and copy it to the remote machine, which is CloudX Lab, and see how we can actually run it on the CloudX Lab. That is more important. Then we will get into the accumulators and broadcast variables. Now the program is compiled and ran in Eclipse. Okay, but we cannot actually take the source code and run it on the remote cluster. What we have to do, we have to build the jar file. How to build the jar file? You have to go to the directory where your build.sbt is there for the application. So in this case, it is research, live demos, big data, September 2016. Okay, and then here, what I have to do, I have to run sbt package. So it has generated the jar file. So you can copy this path. Okay, scp signing my user ID at CloudX Lab, one of the hosts, and then we have to give the path. So this is my user ID at the rate host name colon tilde stands for home directory. It can also be represented as home slash training 8634. There could be exceptions, but typically this will be the home directory for most of the users by default. At times, the Linux admins might create a different one also. So now the file, the jar file is copied. Okay. Now I am actually going on to the host 8634 at f.cloudxlab.com. Okay. Here, when the jar file is built, the jar file is built with the resources. So the application.properties is already part of the jar file, and the application and the logic of config factory.load will actually load the properties when we actually submit the job. Okay, so in this case, we have hard coded that in production, if the parameter is passed as production, it has to run it in yarn mode only. So if the third parameter is prod, you have to only run it in yarn mode. Okay, so for that, so we will go step by step. So first we need to validate whether we have the input directory and also the output, the parent directory of the output directory, and then only we will be able to run the program. So I have already copied the files to HDFS. So here we are running on the Hadoop cluster, and Hadoop and Spark are already integrated. And by default, it will expect the files to be in HDFS. If you have on different file system, you have to change the path accordingly, which I have explained earlier as well. So in this case, we are only working with HDFS. So we don't need to hard code the name node directory and all those things, because and the Spark is integrated with the Hadoop on this cluster. Okay, so /user /training 8634. In your case, this user should be this directory should be your username /data retail_db. The files are there. So we want to process orders and order items under this location. So this can be the first parameter for our class. and the second parameter is the output path. So Hadoop fs -ls user training 8634. I just want to create a directory called output over here. Okay, it does not exist. Even if it exists, our logic, our program have the logic to delete and recreate. So I will be using user training 8634 / output as the directory for the to store the output of my application. Okay, and then the third parameter is prod. We can actually do it as dev also. If you do it as dev, it will run in the development mode. So first I will run it in the in local mode. So first I will run it in local mode by passing dev as parameters. Then I will be running it in yarn mode by passing the third parameter as prod. Okay, so spark submit command takes. Let me go to syntax is a little bit complicated. So let me go to the topic here where I already have the syntax to submit the Spark job using the jar file. So this is how you typically run Spark submit. First, you have to pass the class name. Okay, jar file name we have to pass later. It's weird, and the order is mandatory. You cannot just pass the way you want. You have to follow a particular pattern. Spark submit, and then you have to give all the parameters related to running the job, and then you give the jar file. It's weird. Ideally, it should be jar file first, but that is how it is. Okay, so Spark submit. Our class name is, in this case, this one. Retail is the package name, and then this is the class name. You can give slash to break into multiple lines, and here, if you see here, I am specifying master yarn executor memory and total executor cores. For local mode, you don't need to pass these parameters. You can just ignore all those things and directly give the jar file name. What is the jar file name here? The jar file name is this one. You need to make sure that you are in the appropriate directory, and then we have to pass the parameters: input path, output path, and the environment or the mode in which the application needs to run. So the input path, I'm passing it this one, which is the base directory, and the output path, output, and dev. Because I want to run it in local mode first, that's why I'm passing it as dev. And then I'm running the program. So you can see that it has read the data. If you go through this content, you will understand most of the stuff. There are some complicated stuff which you might not understand to begin with, but over time you will be able to get it. So it's very important to get the knowledge of all the information which is emitted as log messages when you run these applications. Okay. For now, the most important thing is the input split, from which it is actually reading the data. Okay. So it is reading from order items, and also it is reading from orders, and then it is trying to run the application by reading the data from the input path. Okay, now we will see Hadoop fs -ls /user /training 8634 to validate that the program has ran successfully. So it has created a directory called output here. And you can see the file here, part -00000, and it will be better to actually cat the output to make sure it has the results in the expected, it has the results as expected. You can see the average revenue for each date. You can also say WC-L to see how many records it actually written. It has 365. We have 1 year worth of data, so the results are correct. Okay. So now we ran in the local mode. We have to run it in the yarn mode or mesos mode. Whatever cluster mode you want to run, you can run it. Generally, in prod environments, these are run part of a script to automate if it's daily job. Yes, so this will be wrapped into a shell script, and that shell script will be scheduled using enterprise scheduler. It could be AppWorks or Control M if you are familiar with enterprise scheduling tools, but there are much better alternatives, open source alternatives these days. One of them is Azkaban. So the spelling is this one. This is from the LinkedIn, and also there is one more called Airflow. So these are getting more popular in the big data world where you can schedule the jobs using the schedulers in them. Okay, you can also create a workflow and then you can schedule it. So there will be a wrapper on top of it and which will be used to schedule. So now we will run it in the cluster mode. If it is mesos, the mesos server name and port number has to be part of your properties file, and that will be retrieved at the runtime, and it will run in the mesos mode. If it is running in yarn mode, you have to not only say yarn client as part of your configuration properties. So here we have to say yarn client if we have to run it in the yarn mode. But when you are actually running it, you also have to say master yarn. These two are not mandatory, but I am using these things so that the program will run without running into out of memory issues, even on the smaller clusters. Okay, this one I added it while testing it on my machine on Cloudera Quickstart VM, and also we don't have huge amounts of data, so this is more than enough. You can actually run your program like this. Okay, so let me see this. If we automate the job, so there is a question from Jiva. If we automate the job, how to we specify the command line arguments? Yeah, you just have to this is nothing but a shell command. Okay, you just have to copy paste this command as part of the script. That's it. You don't need to do anything else, and the arguments are also included. So when you actually copy paste it in a script, let me show you. In this case, I am actually saying spark submit .sh. It's a good question anyway. So this is how you can actually say. Here we have to give the package name and then class name. The class name is this one, average revenue per day. Okay, and the jar file name is okay. So we pass the parameters. Okay, now if you look into this properties of this file, There is no execute permissions here, so you have to say chmod press x spark underscore submit dot sh so that the script can be executed, and then you have to say dot slash. If you set the path, you don't need to say dot slash. Otherwise, you have to say dot slash, or you can give the fully qualified path for the script and hit enter. It's running. Okay, you can just copy paste it. Now you can see that it is running a little bit differently, and we will see the logs also for this. Okay, if you scroll, let me close this one. There should be path somewhere here when it submit the yarn job. Yeah, so this is the 1 minute. I think this is the one. No, no, not this one. Yeah, so it will actually give that application master IP address. Let me see where it is. Yeah, this is the one. Tracking URL. So once it is done, we can actually see the results by using this URL and see how it is running. You can open this one and you can see it's a multi-step application. It has 4 stages in it. The first one, so the logs with respect to Spark are a little bit different. And here you can see that it is not going to the job history server. If you recollect from the MapReduce, when we submit the job, once the job is completed, it goes to the job history server. Here it goes to the Spark history server. Okay, so for each and every technology in Yarn, you need to have a separate history server so that you can get the logs for the application that ran. And you can go through these things the way I'm showing. So you can use the tracking URL. Once it is done, it will go into the history, and you can go to the history and see how the program is running. So if you want to understand how the program is running, this is the way to go. You can also see how much data is input and how much data is output at the final step. So at 0, I let us see. Yeah, the stage 0, it has read the order items table. At stage 1, it might have read the orders table. Yes, or orders dataset. At stage 2, it's a shuffled RDD. We have that reduced by key on the order items, so it might be doing that one here. And then at stage 3, it is again showing shuffled RDD. Actually, the details are hidden here. It is not showing properly. If you go to the steps, you will see wherever it is doing the joins, reduce by key, aggregate by key, all those details you will see. Probably, I think it is in the executors. If you go to executors or something, you will see those details. Okay, so I don't want to get into too many details here. You can also explore and you can also understand how it is going internally to troubleshoot in case of the any performance issues, whether where it is being saturated, where IO being saturated, where memory is being extensively used, etc. And if there is a better way to deal with the problem, you have to fix the problem by redesigning or rewriting some of the components of your application. Okay, so this is how you can run the application in the yarn mode. And as you see here, when I run the Spark submit job, if you open the file, let me mute here. Someone is unmuted. Okay, now it is fine. Okay, so now again I'm going into this spark submit.sh script, and what I'm trying to do is I'm saying the program has to be run in the yarn mode, and then we are also passing we are throttling the memory and executor cores. I'm only using one executor core in this case, and I'm for each executor I'm using only 512 MB RAM to run this application. I'm throttling the memory usage when it is running yarn mode. If you remove these things, it will use the default values, and it might have some issues when you are running in the lightweight cluster, such as your Cloudera Quickstart VM. Unless you add these two lines, I don't think you will be able to run on the Cloudera Quickstart VM. It will run out of memory issues. Only for that reason, I have added these two lines. Otherwise, those are not mandatory. And then we have passed the jar file name, the input path, which is base directory of all our files, and then output path, and then the environment or the mode which we need to run. In this case, we are actually getting from the application.properties using the deployment master as the parameter name to run in yarn client mode. Okay, so any questions here? Okay, then we will go to the next topic called accumulators. So first we'll see what is the importance of the accumulators. Accumulators are typically used to determine is to perform the unit testing and also for the data quality. However, accumulators in Spark is not as robust and as reliable as MapReduce. Okay, and when you actually try to do these validations, you should not use counters, the typical way of counters in the programming paradigm. For example, it is trivial, means typically people do, if they want to see how many records are processed, what they will do, they will say val counter equal to 0, and then as part of the application, when the map function is, for example, let's say I want to see how many records are processed from the orders table. So they say order, we can say in typical programming, we will say orders counter equal to 0. So we are initializing it. And when we are actually implementing that filter logic here, we tend to increment this value. Okay, I think syntax is not correct. Okay, we have to say it as where, because we are trying to increment the value, right? That's why we have to say it as where. So if we say like this, I think plus plus is not the valid syntax in Scala. If we say like this, we will think that it will be incremented. But the way the program will be executed is the Spark based applications will be compiled into DAG. Okay, thank you, Jiva. Yeah, we can use that one. Orders counter plus equal to 1. We can compile into the program will be compiled into DAG, and that DAG will be executed on the cluster. So certain components will be running on one node, and certain components might be running on other node. Okay, for that reason, we cannot use global variables like this. The scope of this, even though it compiles in Eclipse, and also sometimes it might show you the correct results when you actually run it in the local mode, but when you run it on the cluster, it will not show you the correct results. For that reason, you should never use variables directly like this. For that purpose only, we will start using accumulators. In case if you want to see, if you want to validate your data, how many records are processed, how many records are bad records, how many records are good records, etc., you have to use the concept called accumulators. You should not use global variables like this, because the scope of the variable might not pass on to the and the map functions are sorry, the executors which will process the map logic, reducer logic, etc. Okay. Instead, we need to use the accumulator, which will be managed by Spark. Accumulators will be passed to executors, and scope is managed across all the executors of executor tasks. Okay. We will see how accumulators are implemented, and also we will see issues with respect to accumulators. So take our program, the same program, average revenue daily, and let's say I want to see how many orders are completed. So this is how we can actually define the accumulator. Okay. In this case, just before we are applying the filter logic, we are adding this one. So again, we are using SC. Okay. So already we have seen sc.text file. We have seen sc.hadoop configuration, and now we are seeing sc.accumulator, and in future we will see few more things such as sc.broadcast. So not only for reading and reading the files, SC provides many APIs to control how your MapReduce application might have to run. Okay. So here I have created the variable orders completed accumulator, and then I want to so in this case I'm actually incrementing two variables. One is orders completed accumulator, and the other one is orders filter invoked. So how many rows are filtered also I want to see. If you want to see, you have to so in sorry, this one is filtered orders, how many after applying the filter. This one is on how many orders the filter function is invoked. Okay, so this will actually give the total number of orders, and this one will only give the completed number of orders. So I have created two accumulators here, and for each and every iteration of filter, I'm incrementing this order filter invoked accumulator, and when the filter logic is true, when instead of just passing it as an expression, now I have created the if condition. If the order status of a particular order is completed, then only I am incrementing this orders completed accumulator. Okay, and then at the end we just need to return true or false. So the same logic which is used here is also used here, so that it returns true or false for each and every record. If the order status is completed, then the record will be accepted, otherwise it will be discarded. Okay, so this logic will give you both total number of orders and also total number of completed orders. Okay, so here I am not going into developing the whole thing and showing for you. If you want, you can actually go through this code and also go to the videos which I have explained a lot more in detail. But for now I will just use one accumulator, and I will explain you how to compile the program and how to validate, where you will see these results. Okay, so now what I have to do is I just have to say this logic. Okay, here I'm trying to run in the multi-line code. That's why I'm using angular brackets here, not angular. I don't know what braces. I'm using braces here, and then in this I have this condition. If the order status is completed, I'm incrementing orders completed accumulator, and then I'm returning true or false. Okay, now we compiled it, we saved it, and then we can compile it by running sbt package. Every time you make the changes, you have to run this sbt package to build the jar file. And then scp. sh. We can run spark submit.sh. So sbt compile command, what it will do is sbt compile with tilde. You can't use for this scenario. So in case if you make the modifications in your code in Eclipse and if you save it, and if you want your application to be run automatically, then you can use this one, sbt tilde compile. Okay, so you don't need to uh, package it and run it every time. You just make the modifications to your code and save it. And if you have sbt compile in the terminal, automatically whenever you change, the jar file will be created and it will be run, and you can validate the results. It is typically used for scala based applications. For spark, it might not be that useful, but for scala, when you are trying to actually develop typical scala applications, it might come handy in some cases, not all the cases though. It's just to eliminate the steps that you have to run sbt package and then sbt run to see the results. Okay, so now the program is run, and we have to go to the tracking url here. Okay, so here we can see, let us see which data it has read from here, from this. So we have the logic implemented on orders. So order 1 is actually reading the stage 0, it is actually reading from order items, so you will not find the counters here or accumulators here. But if you go to this one where orders is being read, you can see order completed count here. Okay, so there are 22,900 orders that are actually completed. Total number of orders are approximately 65,000 or something. Okay, so this is how you can actually implement accumulators, and it come handy to perform the troubleshooting when the jobs are run. If you are not seeing, if the results are not consistent, then if you are using accumulators internally, you can go to the logs like this, and you can actually get the details. Okay, so that is about accumulators. Here I am going a little bit fast paced with respect to accumulators. If you want to actually get into the details and use accumulators a little bit extensively, you can go through this video and you can get the necessary information. And then before we wrap up on accumulators, we will see the issues with accumulators. These are known issues. Unless tasks are executed, you will not see details about counters. So unless all the executed tasks are completely executed, you will not see details about the counters. Spark guarantees accumulators to be updated only in first execution. So in case if one of the tasks is crashed and if it is restarted on a separate node, then your results might get inconsistent. So it only guarantees in the first execution of a particular task. It might not guarantee for the rerun of a task which is crashed. If any task is re-executed, the results can be inconsistent. The issue is prevalent in both transformations and actions. You can use accumulators in both transformations and actions, and these issues are prevalent in both the things. I have demonstrated only with respect to transformations. Even with respect to actions also, you can actually use the accumulators. Okay, so that is about accumulators. Not very complex, very simple. But I have heard too many complaints about accumulators because It might not, typically people tend to compare with the MapReduce counters are far more reliable, and hence people are not very happy with the accumulators, but at the same time it can provide some valid information when you run the Spark based applications. And from the certification perspective, HDP CD have accumulators and broadcast variables as part of the curriculum. So if you're planning to give Hortonworks data platform certified developer Spark, you need to be familiar with accumulators as well as broadcast variables. So now we will get into broadcast variables. Okay, so as part of this topic, we'll see details about broadcast variables. At times, we need to pass some information to all the executors. It can be done by using broadcast variables. A broadcast variable can be of preliminary type or it could be a hash map. Here are few examples. Single value, for example, if you want to give a commission to all the, or bonus to all the employees, and if you want to compute uh, the value, I mean every month, let's say, depending upon the performance of the company, you want to give a fixed percentage of bonus to all the employees in an organization. Okay, that common discount percent or common bonus percent can be passed as a broadcast variable, and you can actually use it as part of your application. And also sometimes we want to pass uh, pass certain data set so that we can do a lookup, or if we want to simulate map set join, we have to build hash map, and that hash map can be broadcasted across all the executors. So when very large data set, this is the typical use case where the broadcast variable is used. When very large data set is tried to join with smaller data set dimension from the data warehousing terminology, broadcasting dimension can have considerable performance improvement. Okay, because the joins will happen in the map set itself. If you use it properly, you can broadcast the dimension as a hash map onto all the nodes, and in the map function itself, you can actually do the lookup into the dimension and get the join or lookup done. Okay, and broadcast variables have to be immutable, so you cannot modify the broadcast variables. Once it is built and distributed across the cluster, you should not modify the contents of the broadcast variable, be it a hash map or be it a simple preliminary type. Okay, so now we will define a problem statement. The problem statement is get broadcast variables is very important. Okay, get total revenue per department for each day. So this is the problem statement. So again, we'll be using our retail_db database. You can click on this to refer the data model. We have 6 tables. Let me or 6 directories in our data set. So if you go to data, retail_db and ls-ltr, there are 6 directories for each of the subject, such as categories, customers, departments, orders, items, orders or products. From the database terminology, this we can consider them as tables. And if you go to the data model, here what we are saying, we need to get total revenue per department for each day. Okay, if you go to the departments directory and cat on the file, we have 2, 3, 4, 5, 7 plus 2, 9. Actually, these are the original ones, and these 2 are added for the testing purposes. So let's take, we have 7 departments, and using these 7 departments, we want to aggregate on every day to see what is the total revenue for each department. Okay, that is the requirement. To get total revenue per department for each day. And let us go to the data model here. Open image in new tab. So here department details, we can get it from the departments, and revenue we have to use order item subtotal. Date we have to use orders. So we have to join all these 5 tables and get the revenue for each day. But orders and order items are transaction tables. Products, categories, and departments are small metadata tables or master data tables. So what we will do is we will do the join on these 3 tables, get the product ID and department ID mapping. So we need product ID so that the data can be joined or looked up from order items. And for each product ID, we want to know what is the associated department name so that we can actually get the revenue for each department. So first we will join these 3 tables, get product ID to department name mapping, and then we will create a hash map of it. We will broadcast, which will have the product ID and departments. And instead of using join between order items and the hash map of product ID and departments, what we'll do is we will do the lookup into that hash map, and we will see we will try to get the department name. So instead of joining these order items and the product ID and department name that RDD, we will actually create a hash map of it, and we will do the lookup, or we will actually we will do the lookup as part of the map function in the order items itself. Okay, so that's how we will demonstrate for broadcast variables. And this is how you can read the data of departments, categories, and products. You can actually use uh, Scala IDE for Eclipse. So I'm starting the Scala interpreter here. Create Scala interpreter. And first we need to import. After the import is done, here I want to run it in the local mode. So I have created a conf with local, and then I have created the Spark context object. Then I will create the in-path variable saying /users research data retail underscore db. Let me name it as input path rather than in path. Okay, now we can create RDD for departments, categories, and products. Here you have to be a little bit careful when you try to join these 3 things. Okay, so the outcome of this the join of these 3 are product ID and the department name. Okay, you cannot join products and departments directly. First we have to join departments and categories, get the product category product category ID and the department name, and then you have to join with products using the product category ID, and then you will get the product ID and the department name mapping. So here I am creating the department's name, department's map. So for join, we always have to extract the keys. Okay, this is not ran. That's why it depended to the last command. So I have to fix that. What happened? So let me do it again. So first I will create the departments. It's done. Then categories. Then products. Okay. So we have RDDs for all the 3 data sets. Now what I'm trying to do, I'm trying to get the department ID and department name. So department ID is the key and department name is the value. So I can say departments. Let me departments map dot take of 10 for each println and hit enter. You can see that we are getting the department ID as key in the tuple and the department name as value. Now I am trying to get the categories, and in the categories I am getting the category ID as the key, and uh, then category department ID as value. Okay, and now if I say categories map dot take of 10 for each println and hit enter. So this one is category ID, this one is department name. So 1 to 8 categories, product categories are part of department 2. Okay, the reason why I am using product category ID as key is because if I have to join with products, I need to join only on the product category ID, which is category ID in the categories table. Okay, for that reason, I have created categories map, which have category ID as key and category department ID as value. So first we will join products and categories, and then we will join departments. And now I am creating products map. Here you can see that I am reading the second element as key. Second element is nothing but the category ID. If you go to the picture here, you will understand. Product ID is the first one, which is the primary key of this table, and product category ID is the second column, and we are fetching product category ID as key for the products map. Okay, and now you can say products map dot take of 10 for each println. So this is product category ID and this is product ID. Now we can join products and categories, and then so this is the function logic which will join products and categories, and you can see product categories dot take of 10 for each println. Okay, so this is nothing but category ID. Okay, that is the one which is used to join, and this is one minute. Yeah, uh, this is product ID and this is department ID. Okay, the department is from categories. Okay, now we have to make it as key from this department ID, and we have to get the product ID. We can discard category ID, and that is what is happening here. So if you look into this logic, we are saying reg dot underscore 2 dot underscore 2. Reg dot underscore 2 dot underscore 2 is nothing but this one, which is nothing but department ID. So we are actually implementing the map function to get the department ID as key, and then the so the department ID as key, and then product ID as the value, because we need product ID to join with order items later. So we can discard everything from the categories. We don't need anything from categories because our requirement is to get the revenue for each department. Eventually, we even discard the product ID also after the join is done with order items. Okay. So here we have created product categories map, which have department ID as key. So you can check that. But take off 10 for each println. This is nothing but department ID, and this is product ID. Okay. Once this is done, we have to join with the departments table, and the output of this is nothing but department. Let me see what is the output of this. Take off 10 for each ln. Okay, so the output is nothing but for each product ID, we are getting the department, sorry, for each department ID, we are getting the product ID and the department name. Okay, so we joined all the three tables and we got the department ID as key, and the value of each of the tuple is nothing but product ID and the department name. So we have to discard the department ID now, and we have to create a hash map of this so that we can do the lookup. When we actually apply the map function on order items, we can do the lookup on the product ID and we can get the department name. Okay, so this is the logic which will build the hash map. Here we are just applying the map function and the distinct function, and we are actually discarding the department ID because ID is not required anymore. We just need the product ID and the department name. So now you can actually say dot take of 10 for each println, and you can see for each product ID what is the associated department. Okay, now we can actually broadcast it, and here this will actually create a hash map on the RDD. So this is nothing but RDD. Product departments map is nothing but RDD. And when we say collect map, it will create the hash map. And when we use broadcast API on the Spark context, then it will actually determine that, okay, this hash map has to be broadcasted to all the executors when the program is being run. And the variable name, broadcast variable name, is named as BV here. So we will create this broadcast variable by using sc.broadcast or spark context.broadcast, and we convert the RDD into hash map, and that will be broadcasted eventually when the program will run. Okay, and now we will go through the rest of the stuff. We have to read orders and order items the way which we have done earlier. And here also I just want to get the total revenue for each day for completed orders. So this is the logic which we have seen earlier. Okay, it will actually get completed orders, and also it applies the map function to get the order ID and order date. We only need those two. So we are directly getting the completed orders in this case by applying filter as well as map. And then when it comes to order items map, here we will do the lookup. So this is the logic which you need to focus on. Hello? Okay. So here we are applying the map function. Till here it's pretty straightforward. Okay. But as part of the map function, what we are doing is we are creating the tuple, and the tuple will have so what we need to get the total revenue for each department for each day. Okay, so the first element in the tuple has to be order ID because we have to join with the orders, so there is no change here, so we can just copy paste this one. So the first element of the tuple is nothing but order ID, and the second element of the tuple is again a tuple, and that tuple will have the department name by doing the lookup into bv.value will give you the hash map, and then we can apply get function on that, and then we can actually pass the first element or key to get the department name. What is the key? Key is nothing but the product ID. Product ID is the third element in the order items table. So if you go here and if you go to order items, tail, part, so you can see this is nothing but the order item ID. This is the second element in, sorry, the second element is order item order ID, which is nothing but order ID, and the third element is product ID. So using this product ID, we can look up into the hash map to get the department name. So that's what is happening here. So this logic bv.value will get the hash map, and then on hash map we can actually apply get function, to the get function we have to pass the key, and the key is nothing but the product ID. And using the key, if you use get function, it will fetch the value for you. Okay. So bv dot value dot get will get the actual record based on the key, and dot get will actually get the value. Okay, and then the second element is nothing but order item subtotal, so that we can actually compute the revenue. So we'll copy paste this piece of code here. Okay, and hit enter. Now, if you look into order items, map dot take of 10 dot for each println and hit enter. You can see for each order ID, we are for each order item, we are getting. So this is the map function on order items. So for each order item, we are getting the order ID so that we can join with orders table, and then we are getting the department name due to the lookup using the broadcasted hash map using this logic. Okay, and then the second element in this tuple is nothing but order item subtotal. From here we can actually compute the revenue by moving the department name to the key, and we can play with it. We will see what needs to be done as we proceed. Okay, so now we can join orders and order items and compute daily revenue for each product. Here the requirement is simple. We just want to get the total revenue for each department for each day. We are not computing average here, so we don't need to get the total number of orders, etc. So we can directly join orders and the order items which have the department name associated with it. Okay, now you can see orders join dot take of 10 for each println and hit enter. You can see order ID as key, and then the value is a tuple, and the first element of the tuple is date, and second element is again tuple which have the department name and the revenue. Okay, from this we have to extract the date and department name, and then we have to apply the reduce by key. Okay, so val orders revenue, and the RDD name is orders join. Okay, in this case I want to apply the map function first and get order date, which is nothing but rec dot underscore 2 dot underscore 1, which will give the order date. And also as part of the key, now I want to make it a composite key so that I can get revenue per day per department. And we have to extract the department name into the key. So how to get the department name? Rec dot underscore 3 dot underscore 1. Sorry, rec dot underscore 2 dot underscore 2 dot underscore 1. I will explain. So rec dot underscore 2 is this one. Rec dot underscore 2 underscore 1 is this one, the date. Rec dot underscore 2 dot underscore 2 is again tuple. Hence, rec dot underscore 2 dot underscore 2 dot underscore 1 will give the department name. So we have date and department name as key. And then value is rec dot underscore dot underscore 2 dot underscore 2, which is nothing but the revenue. Okay, and then we can apply reduce by key, accumulator comma value, accumulator plus value. Okay, I missed some brackets somewhere. Yeah, I think I have missed here. I have to add one more. Yes, I have to add one more bracket here. Dot. Okay, and now you can see orders revenue dot takeoff by dot for each print ln and hit enter. You can see that for each date, for each department, it has given the revenue. To sort the data, what you can do is orders revenue dot sort by key. Then it will be sorted automatically by date as well as by the department name. Then collect dot for each print ln. Now you can see the data for each day, for each department, it has given the revenue. Okay, so this is how we can use the broadcast variable. The key is which one to be broadcasted and how to broadcast. So if you are trying to join a very large table with a small dimension, it will be better to build the hash map of it and broadcast using sc.broadcast, and you have to create a hash map out of it when you try to broadcast a collection of data. In this case, I have created a hash map out of RDD, and I have broadcasted it. And then you can read the broadcast using the variable name bv.value, and then you can, if it is hash map, you have to use .get again here. If it is not hash map, then you can directly read it using bv.value for preliminary types. Okay, for hash map where you are doing the lookup, you have to do the get function to get the value for the passed key. Okay, and then we joined the output of the order items after fetching the department name along with order ID and revenue with orders, and we got the total revenue for each day for each department using the entire logic. And the complete program you can copy paste from here. It has included everything. Now you can compile this, build a jar file, and execute the application on remote cluster. And I will leave it as an exercise to you so that you can go through this, tweak something, and try to redefine the problem statement and write this program. If you are able to run this program, you will be covered with map function, you will be covered with filter, you will be covered with reduce by key, you will be covered with broadcast variables. You can also include accumulators a little bit here, and then you will be able to understand how an application can be built using several APIs in one shot. Okay, this is more important. And let me see if there is any remaining before we wrap up for today. Yeah, that's it for Apache Spark with Scala. There is a lot more complex problem if you go to my certification courses, and if you go to CCA, Spark, and Hadoop Developer. I deliberately did not include as part of this course because the purpose of this course is a little bit different and it deviates from the certification a little bit, but there is a significant overlap. If you go here, and if you want to understand how to do sorting and ranking, which is not covered as part of this course, if you want to explore sorting and ranking, especially by key, I will highly recommend you to go through this topic, which is part of CCS, Spark, and Hadoop Developer. Probably I will provide the link as part of Apache Spark with Scala in Big Data Engineer also. So in this, I not only focus on the APIs, but also if you go through here, I have demonstrated how to use group by key effectively, where the group by key actually used in real world scenario. So far I haven't covered group by key as part of the demos, but I have explained what is the difference between group by key reduce by key and aggregate by key. Group by key is also very important transformation, and it's complex transformation, and you need to understand that if you want to explore that, especially from the certification perspective. If you want to give any of the certifications, I will highly recommend you to go through this topic. So Srinivas is asking, can we use more than two variables as composite key? Yeah, you can use, you can make it as complex as you want as composite key. You can even create an array as a key. So
hello, Durga.
yes.
Can you hear me?
Yeah, I can hear you.
Hello, Durga. When we schedule staff jobs,
Yes.
let's say we schedule the job to run on daily basis.
Uh-huh.
So the application goes to the particular directory and reads the file for processing.
That's correct.
Input part.
Yeah.
But when we import data, for example, let's say scoop, we use scoop to import data to the particular directory.
Uh-huh.
We process the file. We don't want to process the already processed file.
Yeah. So yeah, go ahead. I understand. I understand your question. Go ahead.
And similarly, before deleting the output path,
Uh-huh.
we want to save the analyzed file in somewhere so that we can use for later purpose.
No, we don't delete it in many scenarios. In some scenarios, we delete it. In some scenarios, we create the unique path. So we pass the output directory, the base directory, and as I have explained earlier, typically we will append timestamp for each of the output directory. Okay, and that pattern has to be defined in application.properties. And as part of your application logic, you should be overriding. Let me take you here. So the question is, she is asking how to handle the input path and the output path. First, I am answering the output path. Okay, we don't delete the output directories the way I am doing here. In some of the cases, we do. In some of the cases, we don't. It depends upon the requirement and design. So in this case, what we have to do is, instead of checking if output path exists, delete. What we have to do, we have to have a pattern in application.properties like this, something like this: prod dot output directory pattern. And let's say you want to save it in the and then hs24 miss. Okay, so this is the year, month, date, timestamp. When you want to save it, if you want to save it with this pattern. So as part of your application, sorry, I'm modifying the wrong file. As part of your application, what you have to do is you have to read that value. 1 minute, okay? So you have to read that value, and you have to generate the output path using that value, and then you have to use that one as part of the save as text file. So the output path will be system generated based upon your configuration properties and the parameter you have passed. Either you can make it unique whenever you write into your output directory. That is the appropriate way in some cases. In some cases, you delete and you overwrite with the same directory name. It depends upon the design. You need to implement that logic. Okay, that covers the output path. And when it comes to input path, the way it works is typically we will get into a directory with some naming convention. We even this one, even the retail, in this case what I'm doing, let me, okay, I'm not sharing my screen, sorry. Okay, so let me put you on mute. I'm hearing echo, Jiva. Okay, so I have already covered output path. In some cases we delete and recreate with the same directory name. In some cases we actually create directories with the unique names. When it comes to input, so typically you will have directories like this. Let's say cd data mkdir retail. Okay, so you will have some, let's say you have directory like this. In this you will have multiple directories. One is stage, processing, archive. Okay, again it depends upon your design, how you want to design. If you want to make sure that each and every day's worth of data has to be identified with a date, your directory naming convention should have the date. So even input path also will not be used directly here. You have to derive it. You have to programmatically derive what is the input path that is being processed. Okay, you have to sometimes you even have to store the metadata into a database and read or the you have to log certain information of the previous one into a database, and you have to fetch it from there. So these are all data integration practices. You have to talk with some ETL developer who have worked on this to understand how the design will be. And the design will be typically like this. You have stage, processing, and archive. Even the reason why we need to have timestamps or dates in the input directories also, so that when the data is archived, you know um, which data belongs to which date. So you have to come up with a complete data integration framework, and you have to develop to that. I have simplified so that I focus on the Spark based APIs to explain. Okay, in real world scenario you have to cover all these scenarios about how you should so there is something called this is how the data warehousing or data integration projects work. Okay, so you come up with a design, and you have to work with the source systems which will give you the data. For example, you are working with the mainframes team, and mainframes teams does not let you to pull the data. Instead they push the data to you. And that's where there is something called technical specification. You have to come up with a technical specification saying that I need files in this format, in this location, on at this interval, at this regular intervals. And then you have to pass the technical specification to the mainframes team or whatever team is responsible to push the data to you, and they have to adhere to those specification, and they have to push the data as per that standard. And then you have your design about how to process the data which is being landed based upon the agreed upon technical specifications. And you have to implement the logic to read the data from stage or move the directories to processing before even start processing. Once the processing is done, you have to move the directories that are already processed into archive. Okay, so all these things has to be taken care based upon the design and implementation of your project. With the example which I have given is very simple and straightforward example where I am just validating the input path. And here the reason why I am doing this is you need to understand the file system API which is related to Hadoop, which is not neither related to Spark nor Scala but to Hadoop. You have to use this API to implement your data integration platform to move the directories around. Okay, it makes sense. Yeah, anything else? I can take one or two more questions. So we are done with Spark with Scala. From the next class, we will be focusing on Python. And as part of the Python, I will not be going through the concepts quite extensively, but the sorting and ranking using I will try to demonstrate sorting and ranking using Python by key, so that you understand group by key, the usage of group by key from the Python context. The same concepts you can implement using Scala also. If you want something for reference, you can come back to this. Similarly, for all the things which are already covered using Scala, if you want reference with respect to Python, you can come back to this link and you will understand how it is done in Python for almost all the concepts which I have covered so far. However, I'm not expert in Python, and I don't know how to externalize the parameters, etc. So I will not be covering those aspects with respect to Python. If you are interested, you can explore it and you can write a blog, and I will be glad to publish on my website if anyone is interested in doing so, about how to externalize the parameters in Python and run the application based on the parameters, based on the externalized parameters. How to pass command line arguments, I know. I will demonstrate based on that. But how to externalize, I don't know. If any one of you are aware of it, yeah, and if you want to write a paper or a blog with respect to Spark using externalized parameters from Python, you are welcome to do so, and I will publish on my website with your name. Okay, that being said, thank you very much. I hope you are enjoying the sessions. If you please make sure that you practice as much as possible. If you do not practice, again you will be in the square one in a couple of weeks, because the course is very intensive and we have so many topics that are being covered as part of this course. Hence, practice is very important, and you need to spend at least 3 to 5 hours every week on top of my classes to get up to speed and understand what is going on with respect to all the modules that are covered as part of the course. That being said, thank you very much. Bye.